Number 26 is asking us to determine the height of the tree. So this is our unknown, the height of the tree. Again, we're using similar triangles in order to solve for this unknown height. We know these are similar triangles because we have the right angle relationship between the building and the ground and the tree in the ground. So there's a pair of angles from the small triangle and the large triangle that are congruent to each other. They also share this angle together, and so that angle is congruent to itself by the reflexive property. So by angle, we have a small triangle similar to the large triangle. Since we're solving for x, we cannot use the part-to-part proportion to solve for x. We would only be able to use part-to-part if we were finding one of these parts created by the intersection of this parallel side right here. And so we have to use a small triangle to large triangle relationship to find the height of the tree. So the height of the tree is a side of the small triangle. Its corresponding side that is a side of the large triangle would be the height of the building, which is 160 feet. When I go to write the small triangle to large triangle relationship for another side, you have two options here. You can either use the small triangle and large triangle side from this side, or small triangle, large triangle from this side. But you can't do a combination of the two because these two sides have to correspond to each other. So if you use the 144 for the small triangle side, the large triangle side would have to come from this side. So it would be the sum of these. The tick marks show me that this is also 144, so that whole side of that large triangle is 288. You could also have done x over 160 for small to large and then use this side. So the small would be the 120 and the large would be the sum of 120 and 120, since again those tick marks show me congruence. So it would be 240. Either one of these proportions are going to give you the same exact thing. So when we cross multiply to solve, we have some large numbers that are we are looking at here that we need to multiply together. So we have the 288 times x, that's 288x, and then we have to multiply the 144 by 160 to get 23,040. So when we divide both sides by 288, we get our 288, we get our x value to be 80. So the height of the tree is 80 feet. Same thing we would get if we solved this proportion. One thing I'll tell you is a lot of times kids have a hard time understanding what this 120 is representing. The dimension that's given is usually centered on the segment that it's giving the length for. So I know this 120 is centered between this point and this point, so it's representing that distance. If it gave me the 120 feet right here, right under the tree, then that would mean it represents this whole distance right here because it's centered along that distance. So that's kind of an important thing to notice on your test that's a little bit different than this diagram. If something is centered along a segment, it represents the whole segment. Here it's only centered between here and here, so it only represents this distance. So be sure to look out for that.